Slope is rise over run is one very popular thing. Okay, Dimitri, what's the second one?
Well, I know there's something with y equals mx plus b, and I know that m is the slope, and that m.
Okay, I'm gonna jot that kind of over here in the corner because it doesn't really. So I'm gonna jot it above.
Oh, I didn't know.
This formula is not a slope formula. It contains slope, and that m is the slope, but it's not the slope formula. That's actually called the slope-intercept formula line. We'll be using that tomorrow when we actually do more graphing of lines. Okay.
The slope formula is y or m equals y2 or y2 minus y1 over x2 minus x3.
Okay, here's an algebraic formula to calculate the slope if you know 2 points. Subtract the y's, subtract the x's, and divide. How's some other, anything else we know about slope? Luke?
If it's straight up and down, it's undefined.
Straight up and down, what's another word for straight up and down? Undefined with a, for some reason, a really large written E. Kate?
If it's horizontal, it's 0.
Vertical slopes are, vertical lines have an undefined slope. Horizontal lines or horizontal slope is equal to 0. Those things came out last hour. Is there anything else? Anything else that's distinctive that you call about slope?
Slope shows how steep a line is.
Okay. On a graph, it shows how steep. How steep a line is. Shows how steep a line is. Is there anything else? I agree these are all true facts. Anything else?
Something obvious.
No, I just want to know if you think of anything else.
First most common thing that's said.
The mx plus b, which isn't actually a slope thing. Anything else?
Isn't it? I had something smart in there.
So the last thing that I'm thinking of is going to go right in here. Because it's kind of the overarching idea. These are all components of slope. But can anyone describe me what does slope like physically describe? Like if you're in a if I'm giving you like a story problem or a situation and you calculate a slope, what does slope actually like represent? What does it mean? What does it tell us?
The change of the line, like
Time. That's the drop.
All of these things that we wrote down all kind of fit under this umbrella of what's called rate of change. Slope is that. It's a speed. It tells us how fast a quantity changes. And if we can remember this idea, all of this stuff fits under this umbrella. This is the equation that describes how fast your situation is changing. These are some specific cases of change. Steepness is like a visual description of change, of rate of change, but it all comes underneath this umbrella.
But I didn't before when it's eventually or.
No, please leave slopes as fractions, as improper fractions.
Okay.
Don't write them as mixed. They're not very useful as mixed numbers, and they're even less useful as decimals. Leave them as improper fractions, if at all possible. Proper or improper, leave them as fractions. You get negative over negative, that's a negative divided by negative is a positive number. 16 over 6 the same as reduced to 8 over 3. Okay. But also, just so we're 100% on the same page, there could be four different ways to describe slope, I guess. And we're always going to talk from left to right. You could have a rising line, which would have a slope that's positive or bigger than 0. If your slope is positive, we know the general shape of the line must be going up from left to right. It could be falling, which means we have a negative slope, a slope that's less than 0. That means it's going down from left to right. It can be a horizontal line, as we described earlier. That's when our slope is exactly equal to 0. That's when it's nice and flat horizontally. Or you can have a vertical line. Vertical. And that's when our slope is undefined. What's really at this point the only way we know how to get an undefined number? How do you find that a term is undefined? Lucas? You divide it by 0. It's the only way to get an undefined quantity is to try to divide it by 0. So if I told you this, the equation of a line, or I gave you a couple points and I asked you to describe what the line looks like, give me a description of what it would look like. Is it rising, falling, horizontal, vertical? Compare the slopes. Positive numbers are going up, rising, falling, and so forth. How would you find the steepness of a line? How would you describe, just by looking at the slope, how do you know what like a relative steepness would be? Like, first of all, what is steepness?
How fast a line goes up.
How fast a line goes up or how fast a line goes down? How would you tell that just by looking at the slope if I didn't have it graphed? If you didn't graph the line, how would you tell which lines are steeper than others?
Lines with a higher slope would have steeper.
Larger absolute values have steeper lines. The steeper the line has a larger absolute value of slope. What I mean by that is the slope is farther away from 0. So really, really big positive numbers have really, really steep slopes. Really, really big negative numbers have really, really steep negative slopes. And as you get closer to 0 on your slope, then the line gets flatter and flatter and flatter. And the farther away from 0 you get, the steeper and steeper you get, whether it's positive or whether it's negative. They get steeper and steeper and steeper. Kind of the heart of the matter is why we're even bothering with slope in this today is that we want to eventually use them to find lines that are parallel and lines that are perpendicular. The slope of two parallel lines, if you recall from last year, maybe you didn't, but the slope of two parallel lines have equal slopes. So in algebra fashion, M1 is equal to M2. Parallel lines. So I don't really have any much more to add to that. The parallel lines, if your lines are parallel, then they have equal slopes. If your lines have equal slopes, then they're parallel. It's a biconditional. So lines have parallel slopes if and only if they have equal slopes.
How would that work with like a vertical line and a horizontal line?
Perpendicular lines. Their slopes have the following property. That if you multiply their slopes, then they're equal to this constant number, -1. They have the following property. If you multiply the two slopes of perpendicular lines, then their slopes multiply to -1. Well, let's expound on this. So what does that actually mean for the relationships of the two slopes? I could say solve this equation to get, say, just one of them in terms of the other. So if I say divided both sides by m1, we get this new thing. We get this relationship. That m2 should, that means that m2, the second slope, is forced to be -1 over the first slope. Anyone know what this thing's called? If you say just flip, say
Reciprocal. Inverse.
it's an inverse, it's a reciprocal. And it's also divided by, it's over -1, it's not over +1. So maybe this hopefully will ring in some bells. Perpendicular lines have opposite reciprocal slopes. Opposite reciprocal. Opposite meaning it has a different sign. There's the opposite sign. If one was positive, the other's negative. If one was negative, the other's positive. And they're reciprocal, or they're flips of each other. And when we multiply them together, we should get -1. So using these two statements, if I give you some points, you should be able to tell me something about the lines. If I give you two lines, or points that are on two lines, and I say, tell me if the lines are parallel, perpendicular, or neither of them. Well, if you want to know if they're parallel or perpendicular, you better know something about their slopes. So find their slopes, and then compare them. Let's find the slope of one. Our slope of our first line is, I'll use my slope formula, I'll use y2 minus y1, 2 minus 8, x2 minus x1. -6/2, which is -3. Slope of our second line, -1 minus -2 over -4 minus -7 minus the negative is the same as 1 over 3. Are those lines parallel, perpendicular, or neither of those relationships? Why are they perpendicular? Because they are opposite reciprocals. You put this over 1, and voila. Those are perpendicular lines. Then let's take it a step further. Here's the situation. Line H passes through 3, 0. 1, 2, 3, 0. And 7, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. And 7, 6. Line H.
I can do that with my pencil.
Here's line H. Graph the line perpendicular to H that goes to the point 2, 5. 1, 2, 1, 2, 3, 4, 5. Here's 2, 5, and I want a line through that point that's perpendicular to this one. Well, you should be able to do this without using, say, a protractor or a compass, or whatever you want to use. You don't need a protractor to draw a perpendicular line, draw a 90-degree angle. What should we know about those two lines then, Joel?
Well, when you try to find like the slope first,
When we find the slope of our first line. Thinking ahead, what's that going to do for us? If you know the slope of the first line, how does that help? Paige? Then you can find the opposite reciprocal. We'll tell you the slope of our second line. And then we can use that to get some points and graph our line. So what's the slope of the first line?
3 over 2.
6 minus 0 over 7 minus 3. 6 minus 0 over 7 minus 3, which is 6 over 4, which is 3/2. If I say this is my second point, y2 minus y1 over x2 minus x1. Simplify. The first slope, or the slope of h, is 3/2. So what should the slope of the line that's perpendicular be? Perpendicular slope should be opposite reciprocal. Negative 2/3. How in the heck are you going to use that to graph a line?
Go down to the point that you're at.
Well, you go down 2 and over 3, and you can repeat that over and over again and get a line, for sure. Is this the same as this? Are those two things the same?
Yeah.
This first thing is saying go down to right 3. What's this tell us to do?
Left.
Same.
Does that give us the same line?
Yeah.
Up to right 3. Oh, sorry, up to left 3. Yep, you're absolutely right. Oh look, that gives you all the same line. And that line also happens to be perpendicular. Beautiful.